Good morning, everyone. Myself Gupta. I'm going to explaining DMVPN. So before of that, just I want to creating one of the network diagram, simple diagram. So that is containing with three of the routers and one of the switch. So I'm creating the network diagram now. So these are the three routers. I'm going to connect into the one of the switch. I'm connecting to fast Ethernet 0/0 of the all of the routers to the one of the port to the switches. So these are the three routers. I'm going to explaining with in a practical scenario for the DMVPN. So this is the DMVPN. So what is meant by DMVPN? What is meant by VPN and a DMVPN? So DMVPN is the Dynamic Multipoint Virtual Private Network. So previously we were having a static, mean that point-to-point tunneling. The static tunnel is called a GRE tunnel, and it is connecting to in between of point to point. So that is just called a static VPN. With the support of the GRE tunneling, we are going to creating a static, and we are configuring a static route also for that. But coming to here, the dynamic multi-point VPN network. The dynamic means dynamically the VPN session will be appeared. So how? Here the dynamic multi-point means here the dynamically routing protocol we are using here. That dynamic routing protocol means in the routing protocol we are having three types of routing protocols. First one is a static, dynamic and default routing protocol. Here we are using dynamic routing protocol. And also if you consider the hub and spoke topology, the spoke and the hub, we are going to creating a tunnel in between offices dynamically appear in DMVPN. And this VPN after appearing, after connecting the TM VPN between of these R1 and R2, it will check for a certain time of interval. If the traffic is flowing for a certain time of interval, then the session will be continued. And if the traffic is not flowing in a particular timing, the session will be expired and it will be flushed out from the NHR table. What is mean by NHRP? Next Hop Resolution Protocol. So it is like as an ARP routing protocol. The NHRP is used to register a tunnel to the from spoke to hub. Mean if R2 wants to create a DMVPN with R1, the NHRP command is used to register the R2 with R1. So basically the we are configuring the basic commands to register R2 with R1. The mainly the DMVPN is if we configure the both of the spokes R2 and R3 to communicate the hub, the R1, after session was expired, after session was created, not expired, after creating the DMVPN, both of R2 and R3 can communicate with each other without of any support of R1. So here the mainly concept is coming to that GRE tunnel. What is mean by GRE? Generic routing engine. The GRE tunnel, when we are using the GRE in that static, I mean the static VPN, the GRE tunnel is using for to creating an encapsulation from point to point. So if the traffic is going via an internet or insecure path, So the packet or the network may be affected due to of any security issues. So to avoid those issues, we are going to using a GRE tunnel with the support of IP security. So what is the difference between a GRE IPsec and IPsec VPN? So in GRE tunnel mean that static VPN static VPN is allowing to multicast, but in IPsec VPN it will not allow multicast. It is only for unicasting only. So in that way, on the basis of that static VPN, here we are going to creating a DMVPN here. And few more I want to discuss here. If I'm going to creating a static tunneling with the support of GRE from R1 and R2, from R1 R3, we have to create different of tunnels interface and different routings to configure a static tunnel from R1 to R2 and on R1 to R3. But coming to DMVPN, we don't want to create a number of static routes required here. So with the support of dynamic routing protocol, the session will be automatically, the neighbor will be formed with R1 and R2, R3 and R1. So dynamic routing protocols mean that here we can use both of any of the routing protocol, either EIGRP or OSPF. And so just I'm going to starting the configuration of the DMVPN. So on the command basis, for every command, I will try to explain what is the use of the command, how the DMVPN will be formed. Now I'm going to enabling all these routers to work on the CMD prompt. So yes, now all these routers are showing fine. So I want to configure from R1 the console cable. Going to configure here. Now I'm trying to configure the router R1 with the IPs of tunnel and loopback IP and first Ethernet IP addresses. Yes. So I'm going to configuring these loopback interfaces. Interface loopback 0. IP address is 1.1.1.1 and 255.255.255.255. And the same way, I'm going to assigning an IP address to first Ethernet 0. The IP address is, you can assign 192.168.120.1 in the classes subnet. And I'm going to creating a tunnel, the tunnel interface, zero, and I'm going to assigning an IP addresses to this tunnel interface. It is 172.16.32.1 with classes subnet. Okay. Okay. So what is the interfaces was created or not? Just I'm checking. The first Ethernet is showing the administratively down. No shit. Yan. Okay. The loopback interface was created and tunnel interface was created. and we are assigning an IP address to the first Ethernet IP addresses, and I'm going to creating the R2 as a CML console. Config T interface first Ethernet 0/0, no shit, IP address 192.168.120.5, clean classy subnet. Interface loopback 0. The IP address 2.2.2.2, 55.55.55.255. I'm creating the tunnel interface the same well 10.0. The IP address is 172.16. What do we have to assign? Dot 120.2. Oh, sorry, I have to give, forgot to give subnet mask 0. So I'm checking what are the interfaces are created and IP addresses assigned. So the first Ethernet is physically app, and then the IP address was assigned, and the loopback interface was created, and tunnel interface created, and tunnel interface is showing down. Okay, the protocol is showing down. The same way I'm going to also configuring that R3 as well. Config T interface first Ethernet 0/0, no shit, IP address 192.168.120.6, class C subnet, and also I'm creating the loopback 0, IP address 3.3.3.3, 55.55.55.55, and also creating tunnel 0 interface, IP address 172.16.120.3, class C 0. Just I'm checking what are the IP addresses and what are the interface status. The interface was assigned loopback 0. Okay, just I'm checking whether I'm able to reach out to that other interface also. Ping 192.168.120.2. Oh, sorry, 5. The second one I'm trying to reach. Yes, I'm able to reachable. 6. Yes, I'm able to successfully reachable to both of these. Yes. So now I'm going to creating the tunnel interface configuration for DMVPN now. So what are the commands are required for to creating a DMVPN in that R1? So all these routers are able to reachable from one router to one router. So in the R1 I'm already created that interface tunnel 0. Okay, under the tunnel interface I'm going to creating the DMVPN. Here I'm going to creating the mode tunnel mode GRE multi-mode. If you are forgetting, if you have forgot, or if you are not giving the multi-point word here, these come under static. The tunnel mode GRE means only the static. We have to put the multi-point also here. So it will, after giving this command, it will come under multi-point. So what is the source? What is the tunnel? GRE, we already given the mode is multi-point. What is the tunnel source? The tunnel source is fast Ethernet 0/0. So if any of that R2 and R3 want to communicate with tunnel, so we have to map that fast Ethernet, mean that how it will be communicate. So the tunnels in R2 and R1 directly will not communicate. With the support of the physical only, they can communicate. So the tunnel source, where is the source of the tunnel? With the support of the source of the tunnel only, the R2 and R3 of the tunnels can reachable to R1's tunnel. So the fast Ethernet is the tunnel source. The tunnel source is the fast Ethernet 0/0. And I'm going to configuring NHRP. I'm already explained at the initial of this video. The NHRP is Next Hop Resolution Protocol. The Next Hop Resolution Protocol, in the sense, it is working as an, it is one of the address resolution protocol, next hop resolution protocol, and it is used to allow allows the next hop client, mean that the B mean that R2 and R3 can register dynamically with R1. So this is to register dynamically both of R2 and R3 to hub, means R2 and R3 are the spokes to register to R1. So NHRP is the next hop resolution protocol is used to register both spokes to the server, mean our hub. The next hop IP address, sorry, next hop resolution protocol mapping. Map means we are going to mapping multicast dynamic. So the multicast dynamic means the multicasting. So here we are going to using the multicast routing protocol. So dynamic routing protocol, not multicasting, sorry for that. The dynamic routing protocol, in the sense, the dynamic, how the neighbor should be formed in the dynamic routing protocol, so with the support of the multicasting only. So if you are considering in EHRP, what is the multicast IP addresses? It is 225.0.0.10. So if you are not allowing the multicast IP addresses, then the neighborship will not form. So the registration from the spoke to hub NHRP multicasting dynamic, it means we are not configuring statically, it is dynamically appearing with the support of the multicast. So we are going to configuring IP NHRP mapping multicast dynamic. And one more I want to explain to you. So if R2 and R3 need to register with R1, how trustable it is? So there are so many routers will be there. The traffic is going via the internet or in a secure path. So any of the router is need to communicate or register with R1, how it will be reliable? So before of that, it is if R2 wants to register with R1. So basically it has to follow two of them. The first one is a network ID match with R1, and the next one is that next one is group ID. So if the same of the group IDs and network ID is configured as an R1 with similar to R2, if both of the R1 and R2 are having the same similar network ID and group ID, then the neighborship will be formed and the DMVPN will be formed. So to provide that, so we are also configuring for on the server side and the client side. So I'm going to configure here for that group ID and network ID, and HRP for, and that means next hop resolution protocol, and network IDs I'm going to configure with 1, and IP NHRP authentication key is mean that not key, authentication group ID only it is. So I'm going to create it is CCNP. Okay. Here we can also create a tunnel key. This is a tunnel key and some more commands will be there. These are the optional. So I'm going to creating a tunnel key here. The one here. Just I'm checking all of the commands will be correctly configured or not under the tunnel interface. So show run. IP address is 172.16.132.1. On IP redux, IP and authentication, and also network ID will be there, and mapping multicast dynamic, and source is that first 0/0 and tunnel point to point. The same way we are going to configuring on the R2 NAT 3. We are a static configuration from R2 NAT 3 to connect to the R1. Mean that to connect to the server from hub to sorry hub and spoke to hub. And if we are using EHRP or OSPF for a dynamic protocol, all are communicating in multicasting only to form a neighborship. So the mainly the command IP NHRP map multicast is used to form a neighborship which support and allow to multicasting. So that is why we are using IP NHRP map multicast dynamic here. So we are fine up to here the configuration of the R1, and I'm going to configuring for R2. Okay, under the tunnel interface only I'm going to creating the DMVPN config T interface tunnel 0. I'm going to configure tunnel mode. What is the mode? It is a tunnel mode is it GRE multipoint. The tunnel source, what is the tunnel source? Fast Ethernet 0/0. And previously we already discussed, I mean I'm already explained. So if R2 and R3 wants to register with R1 in a internet or insecure network, how can it will be trustable? So we have to configure the network ID and group ID. The group ID and network ID will be same as both on client and hub side. I mean that it like an authentication. The network ID we already configured in the NOR1 is one, and authentication means a group ID. We're going to here, and I'm going to not creating IP NHRP network ID is, I think it will give one only. IP NHRP authentication CCNP are given the router one, and tunnel mode is multiple are given. First Ethernet. Okay, what are the few commands? Tunnel key is one. Okay, now what we have to configure? We already configure the network ID and authentication and key and multipoint and tunnel source. So what we have forgotten? So the only command IP NHRP map multicast dynamic. This is the command we configured in R1. So coming to the clients from main spokes, the configuration is slightly different. Mean I'm going to explain here. IP NHRP map multicast. What is the multicast IP? If R2 wants to communicate with R1, what is the IP address of the R1? What is the IP address of the R1? So the physical IP address is fast Ethernet, this one. But this tunnel need to communicate with multicast with tunnel of the R1. So I'm putting 172.16.32.1 here. Map 1 second, just I want to remembering. 1 second. So one multicast nothing. It is communicating. The R2 is communicate with R1 with multicast of physical IP address only, not tunnel interface. Physical IP address only. What is the physical interface? It is 192.168.120.1. Okay, configured. So if my tunnel interface want to reach out to that tunnel interface in R1, how it will be reached? So the multicast IP with support of the physical IP address of the R1, the tunnel interface in that R2 will reach to the R1. Yes. So here I'm going to mapping NHRP mapping. What IP address need to communicate? I want to communicate from R2 to R1. What is the IP address of the tunnel interface? Is 172.16.32.1. I want to communicate my tunnel in R2 with R1 tunnel. So I'm putting 172.16.32.1. How it will communicate? Support of physical interface of the R1. So 168.120.1. Okay. So if I want to reach out to the physical or tunnel interface, how I reach to? So I have to give in some only one command NHRP NHS. NHS is the next hop self. Mean if R2 advertising that interfaces to R1 without changing, self means with change. Okay, if R2 updating all of these routing tables to R1, so R2 get this information from some other router from R4. If it is not changing that next hop IP addresses while sharing to R1, so R1 will not able to reach out to the R4. So to change that, what is the next hop IP addresses while it is sharing from R4 data to R1? So the next hop IP addresses will be the R2's IP addresses. So I'm putting IP NHRP next hop self IP addresses while reaching to 172.16.32.1. So bus, and these are the commands are required to configure on the spoke side. I'm going to checking all of the required commands are appear or not. Yes, the first one is the first one is the mGRE multipoint. The source, where is the source? Yes, here it is. The tunnel source first in 0/0 and the network ID, and that. So I got all of the required commands in both of R1 and R2. The same commands we are going to replicating in R3, because of the both of the R2 and R3 need to communicate with R1. The support of that multicasting dynamically. So both of the R2 and R3 dynamically register need to register with R1. So the tunnel source interface of that R2 and R3 are the same, and also these two spokes are need to reach out to that R1. So those are the commands are same for both of them. So the both of the configuration only I'm going to configure here.